Ladies and gentlemen, good afternoon. Hope you had a nice lunch break. We're starting off here in room 5 with the next speakers. Please welcome Bogdana, Mostafa, and Anders.
Hi, everyone. So how is your conference so far? Good? Okay. I'm Bogdana Botez. I'm here with my colleagues Mostafa Balat and Anders Larsen. And we are going to talk about design patterns from the latest NAV release, and not only. Talking about CIL design patterns, isn't this a little bit of a contradiction? If you think of CIL as a programming language, you know that it is not even object-oriented. It has no inheritance. It has no polymorphism, no proper encapsulation, no interfaces. So how in the world can we have design patterns on something like that? But I get back to it. For now, I want to ask you, how many of you here are or have been CIL developers? Wow, okay. This is exactly what it should be in this session. So if you are a CIL developer, this might be your day at work, not in the weekend, hopefully. If it's your lucky day, then you get to work on new features. If it's not your lucky day, then you might need to do upgrade. And by now, you are all aware that Microsoft is giving you monthly cumulative updates, which you want to install if you want to be on the latest bits. If you're not doing new features or upgrade, then maybe you get to fix some bugs from the older code that already exists. So, what if working on new features, wouldn't it be awesome if creating a new feature would be quick and easy and a clean thing? And if somebody else has had the same challenge before, they would have documented it, explained it somewhere with diagrams and with code examples, so you can figure it out and not have to reinvent it all over again. What if, working on upgrade, Microsoft developers wouldn't ruin your solution each time we ship a new cumulative update every month, so your upgrade was actually easy and fast? What if, in code maintenance, you could look at the legacy code and understand its intention from the first moment, without having to do reverse engineering and detective work to figure out what's there, which would make maintenance quite fast and painless? So this is all a nice dream slide. And the question here is, what can we do to get a little bit closer to this goal? And it is something that comes after you have figured out what your specifications are, after you think you know what the customer wants implemented, but before you start to write the first line of your code. So let's talk about code design. And this is a time when I am searching for a t-shirt there at Mostafa. I want to ask you if anybody here has read this book. Okay, so there is one person there. And he gets a t-shirt for it. For the rest of you, PRS doesn't count on this one. For the rest of you, I'm going to tell you what it is about. So this book is written by Donald Norman, and it's called The Design of Everyday Things. And it is the 101 of good user interface design. So if you are into creating an awesome experience for your users, I really, really highly recommend it. But this book is not talking at all about software. It talks about doors and door handles and how to design them so you use them correctly without thinking. And it talks about electrical stoves and about teapots and whatnot that you interact with in your everyday life. Yet, when I was reading this book, I figured out that it has everything to do with software. Because today, in today's world, from the moment you wake up in the morning and you click on your phone to turn off your alarm clock, until the moment you go and click on your coffee machine to select one coffee, until you read the morning news or check out the weather. Our life has become everything about software, and we interact with it with almost every step that we take. So I took this nice picture that Donald Norman has drawn, and I changed it a little bit. So now I have a question for you. We have teapot number 1 and teapot number 2. So imagine you have this teapot in front of you, and it contains really, really hot tea. And you want to pour this tea into a teacup. Which one would you rather use? 2. Okay, so that is correct. And the point of this slide, which is obvious, by the way, the point of this slide is how many times have we done this to NAV? How many times did we build a solution that has all the correct elements, that looks okay, but yet something is really, really off? And if the human race has been into doing design for teapots for so much time already, why not use the current design and be performant and use our effort into something new? Okay, enough storytelling. This is what we are going to hear about today. I'm going to talk very shortly about what is a design pattern, why use design patterns, and then we get into the interesting part where you actually get to see some of the patterns. And the first of them are inspired from our work from the latest year, so from the last release. And each one of them is mapped on one attribute that you can make better in your code. So they are like this. They would help you make your code a little bit more extensible, more upgradable, more configurable, adaptable, and more user-friendly. When we're done with that, we have added also some implementation patterns that are very, very close to the code. So we call them cookbook recipes. And they are the following: how to do cached web service calls, how to do a copy document, how to do select distinct with queries. We can do that traditionally we're using temporary tables, and if you search the net, you can find the solution. But now we have queries, so it's a bit more easy. And then at the end, we have added a few of CAL guidelines that we are using internally inside Microsoft when we develop new code. Our intention is to publish them very soon. We have an automated tool that is checking those, so we actually cannot check in if we are not respecting those. So there will be a few examples for you here. We'll end it up by telling you who is part of this project and what's next. So, what is a design pattern? Probably many of you, especially if you have been to the PRS session, or sessions over the years, you have heard about the Gang of Four. If you didn't, they are not some Italian mafia. They are 4 developers who met up a while ago, about 20 years ago, and they wrote a book about design patterns. They took the term from architecture. And this book was about object-oriented languages which can be used to implement design patterns. Since then, it's been very widely adopted by the software community. However, when we talk about object-oriented and patterns, because they are used together so much, we tend to think that design or good design cannot be used outside of object-oriented. And this quote here is by from the beginning of Martin Fowler's book. This is the guy who invented refactoring, by the way. And it says, I quote, "When the Gang of Four was writing design patterns, we knew that there were lots of software patterns other than object-oriented design patterns." And this actually, it is a book about ERP patterns. So if we look at design patterns, this is how it started a while ago. And then the community added more object-oriented design patterns to the ones that were already in the Gang of Four book. And then people like Martin Fowler and many others have added non-object-oriented design patterns. So wherever there is software and there is a problem to solve, you can think of it in terms of design. So why we are here with this project is to add something that was missing, or actually it started to exist but was not named like design pattern, and those are NAV design patterns. We work with NAV, so the problems that we solve are NAV specific, so the design patterns that we solve are NAV specific. And it's intentional that those areas overlap, because we do have patterns like singleton and facade that have been used in object-oriented or not object-oriented languages, but we have also our own that are really NAV. So this is a short definition for a design pattern. It is, and I will read it for you, a pattern is an idea that has been useful in one practical context and will probably be useful in others. This being said, why patterns? That's why. So if you think of NAV with all its code, imagine it is like a watch, a complex watch with a lot of mechanisms inside. And if you look a little bit closer to it, then you can, and pay attention, you can figure out that some of those elements inside our big mechanism repeat each other. Like we have posting, for example. It's part of NAV in many areas. Or like we have the setup tables, which are very specific, actually. They have just one record. They have the key that is empty, and then you can get this record. And it's the same all over NAV. So those mechanisms that repeat are there already, and they are the wheel that it is there for us to take and read about and just use in our solutions. Why else NAV patterns? We have done some research and with our developers trying to figure out what are they spending time on. And if you ask a developer, hey, what have you done today? And he or she will say, yeah, I've been coding. But if you take a look at the actual process, you'll figure out that in order to add new code, they will have to open the existing code up and try to figure out what is there and where to plug it and how it makes sense to plug it. So this means that the more readable is your legacy existing code, the easier and faster it will be for you to add new stuff. And this is a nice comment that one of my colleagues has done. He says, avoid MC hammer code. So do you know what MC hammer code can be? Yeah, exactly. It's a code that says to you, you can't touch this. It's like this big chunk of code that just works, and it's all interleaved, and you don't know exactly why it's like that, and you don't want to touch it because you're afraid to break it somewhere else. So it just stays there forever and becomes these big dinosaurs. Okay, so let's get to the patterns. Pattern number 1 for extensibility is called the argument table. And yesterday, at the end of the PRS session, somebody has asked, knowing that we cannot do function overloads in NAV, how do we solve these needs in a nice and elegant way? There's a pattern for that. It's called the argument table. It does a bit more, but incidentally, it also solves partially this problem. So the problem that this pattern is trying to solve is using too many arguments in a function. And it's a big religious discussion of how many arguments are too many. Some people say that 3 are too many and some that 5 or whatever. But the point here is that at some point they begin to be too many, which makes it hard for you to change the function signature. Because, it's easy to change the function signature, but then you have to change everywhere where it's called. So you do something that Martin Fowler in his refactoring book calls shotgun surgery, like, okay, change it here and change it there, and then maybe there's one place, at least in this case, the compiler will help you and tell you where you didn't change it, so you will not make a bug. There is no function overloading in CLS, so if you want to add one more argument, you have to change the signature and you have to change where it's called. And if you're lucky to use an option type, and that option type definition is changed by adding one more option, for example, you have to change your function signature again. So how to fix this? It's in the title. Just group together your arguments and put them in a table and pass that table to your function, like this. So this is an intentionally exaggerated example, but it's not something that I haven't seen. So this is a function that wants to fill in some data into those vars in order to use it later to fill in a VAT return. And it has some VAT declaration ID, line ID, and a lot of code vars, and then it has a few bools, and so on and so on. So when you get to call this function, you have to kind of remember, okay, the first is easy, second, third, but by the time you get to the end, you might just put true where it's supposed to be false and reverse this, and it's just a bug waiting to happen. So how to make it better? First, you get to make a new table. And here it's called the VAT return data. Then the function signature will be much simpler. It just gets this table. Bonus, before calling this function, you can now assign default values into the fields of the table. For example, I want the number of copies for this VAT to be by default 1. And uploaded is false anyways, but that's an example. And then you get to call the function simply by using the table name. So this time, when you want to add a new field, you just add it to the table. Function stays unchanged, except for the implementation where maybe you want to use this value, but the function call stays unchanged and the function signature stays unchanged. A second example is from upgrade. So if you want to move your data while you do upgrade, then you have to specify the old table ID, the upgrade table ID, and the upgrade mode, which is an option field. If this option field changes, for example, now you have check, copy, move, and force. If you want to add a fifth, then you have to add and change the function signature as well. A better way to do this is to group them together in a table. One thing that we wanted to do with the design patterns is to not only say why they are good, but also why they are bad or when not to use them. So here's the overview. You get fewer arguments. It's a clear intention of what the code does, because now in this table, the field names are telling you what they mean. So you don't have to remember that parameter number 7 was true or something like that. You can assign default values, and then you also can get validation logic inside your table. It's easy to extend because there is no upgrade problem adding new fields. One note is that if you use this table, then the type of the table should be temporary. Because it's not something to persist in the database, it's just a vehicle for your data through the application at runtime. What's not so good about it is that you get to use more objects. And there is only so much that you can do with putting stuff in a table. You can't put a table inside a table. OK, pattern number 2. This is a really nice example of why a community project is better than the sum of the parts. And this pattern comes from one of our partners, from Waldo, aka Eric Wouters, who is part of Partner Ready Software, and he's at iFacto. So the problem that Waldo is trying to solve here is merge conflicts during upgrade. And the more upgrade you get to do, and you have the chance now to upgrade every month, the more you want to solve this thing that is going to become a repetitive part of your process. How to make your product more upgradable? The solution is just try to minimize your footprint. So if you think of the NAV standard code, the one that Microsoft is shipping, think of it as a minefield. The more you step into it, the more chances you have that we'll refactor something and it will just blow up in conflicts next time we give you a cumulative update. And there's the other side of this story. So on the other side, there are Microsoft employees. And I know that each time somebody new comes in my team, they look at the code and say, why aren't we not refactoring this? I mean, it's so obvious what we should do, and we have 3 screens of this function and a few hundred lines. And no, we don't refactor it because we don't want to cause you a lot of pain at upgrade. So then it's like we are keeping this old code, we know it's so easy to make it better, but we refrain from it. Okay, I have like 3 ideas in my mind to tell you, but if you minimize your footprint inside the code, then you give us the freedom to refactor it. And then you give yourself the freedom to have fast upgrades and work on something more interesting. So there are 2 steps to do this. Try to find the places inside the application code where you want to hook in your customization. And write your application code outside and just hook it into minimally from the standard code. And here is an example. On the left side, you can see NAV code, it's code unit 80. And on the right-hand side, you can see Waldo's code, which will be plugged into the code unit 80. So there is a really nice discipline to this hook pattern. And part of it is that if you prefix your code units, your hook code units with the word hook, then it's going to become obvious what is your code, that it is a hook. And even if you get to have a merge conflict, it's really easy to solve it because you don't have to try to understand what was there. And you can read more about this pattern and all the others on our wiki site. But you don't need to remember this because this presentation and all the others will be on Mibuso at the end of the conference. Okay, so what is the result of applying the hook? And this is from a while ago. Waldo was trying to upgrade from NAV 2013 to NAV 2013 R2. And he estimated that after running the merge, and it will take him 2 weeks to solve the conflicts in the whole product code. With the hook, implemented by the book, and I quote, insanely, meaning that he really respected this pattern, the upgrade in terms of fixing merge conflicts took 15 minutes. And here's a nice quote that I'm going to read for you. It says, upgrading from 2013 to 2013 R2, there was a change in code unit 80. Yeah, that's us trying to refactor. Where a piece of code moved to a function. And there were lots of reactions from the community, like, Microsoft, please don't do that. Now my code won't merge anymore. But I only had to move one line to that function. So if there is one pattern that you can start to, find where you get merge conflicts and apply the hook there first. And see how much easier it gets, and then maybe you'll be convinced to use it everywhere else. Okay, this being said, I will hand my presentation to my colleague Mostafa, who will take you through the next patterns.
Thanks, Bogdana. Hello, everyone. So with what Bogdana has explained, we have successfully made our product extensible, upgradable, and we want to improve it even more. So now is the chance for us to make it configurable. In many cases, we have a bunch of code that we have to extend or actually improve the behavior this code is doing. However, we come across very complicated code that is not easy to extend because the logic itself is hard-coded. So what we really want to do is to make as minimal changes as possible when we are adding new behavior or extending existing behaviors so that it's easy to maintain the code later if we want to. Also, just imagine now with multi-tenancy that we have so many tenants on our product, and we want to implement the same change over and over for them. So that means including their customizations that they need. We have to repeat that 100 times, 1,000 times, just count it. So how can we address that? Instead of changing how the code itself is implemented, which basically means the algorithm itself, why don't we change how the code behaves using some data? We configure the code behavior through data, and if we change that, we change how it behaves. Let's just look at an example over here. Speaking of bank reconciliation, where you have some bank account from which you can get a bank statement file, and you already have recorded your transactions within NAV as ledger entries. If you want to reconcile the recorded statement lines against the ledger entries, that means you need to figure out which ledger entry is the one you want to match against. The statement files already have some information like the customer name, the amount, the document number, the date, and so forth. Based on these different values, which will be your criteria, you will be able just to match the statement line against the ledger entry. If we want to implement this in code, how can we do that? The first option we may ever have, and don't recommend it, of course, is that we just write all the combinations for mixing and matching these statement file lines against the ledger entries. That will actually give us a lot of if statements that we refer to as forest of ifs. It has as many if statements as a forest could have trees. But that is very complicated and will just span across so many pages if we just keep displaying that on the screen. A slightly better example, even though it's still not that good, is that we combine each of the logical criteria into one group, and each of them will just become an if statement. That is easier to look at, slightly easier, but it's not that good to maintain or extend later. Just imagine one of these criteria is supposed to change at one point of time. You will have to revisit all these statements. And all of that is going to expand across 3 more screens if we just implement this. Then that just brings us the same idea about using data to control the behavior of an algorithm, if it is generic enough. So let's try to use a pen and a piece of paper to write down these criteria. Each of our criteria is just a column on this drawing. And each of the values combined on a single row will just be one rule. If we have this list and we implement it as a table in NAV, then it will become easier if I have my statement file line and my ledger entry, and then try to think what kind of values I need to calculate to figure out the right rule, and eventually decide if this is a good match or not. So as we look at the example we have today here, I know that I have the customer number in the statement line, and it also exists in my ledger entry. Check. I actually don't have the document number in hand, so I don't have that one. And I know that I should find a single ledger entry. That also check. So I have 2 things to match on, and 1 that I'm missing. Using these 3 values, if I just use this against the table I have just constructed using filtering, then it will be easy to figure out which rule it is, and eventually I can actually determine the confidence level for my match. Easy and clean. How can we ever implement this in code? So for each of the criteria we had come up with, each of them will require a calculating function. So 1 function per criteria. And that is an atomic function that has one responsibility to take care of, and is easy to write. And after calculating these different values, I will actually be able to just apply some filters, and using these filters, I will figure out my confidence level on the match I'm doing. So 1, 2, 3. The table, the calculating function, the filters. Done. What if I want to add more rules? As we described, a rule in this case will be a row on my table. And that means, because it's an NAV table, I can just add as many rows as I want. It's easy if I do that, as long as these still make sense as a rule and not duplicated, because, well, duplication won't help here. But if I add 1 more criteria, that means I need an extra column. And a column in this case will be added to the table. So, for example, if we want to add the criteria for finding those matches that are overdue, then I add a column to the table and just add a few things to the code. The first thing we add to the code is we need to add a calculating function just to figure out the value, if it is a yes or a no, as we have seen in the past slide. And also, I need to add the filters that will just run against the rules table I have already defined. So that is simple. Where else did we use that? We had the data exchange framework introduced 2013 R2, and that helps you create definitions for files that you export and files you import, any kind of files. But mainly we use that for banking and stuff like that. But still you can export any data or import any data as you need. What you do is you describe the format, and after that, the framework will just act on your behalf. The heavy lifting is done, you just define it. The same approach has been done for RevStar templates and configuration templates. You just describe what you want to do using data, and eventually it just works. So what was good about that? First, it's easy to extend. The code is easy to read. And because it's extensible and readable, you will spend less time maintaining that. When it comes to upgrade and merges, your code has a minimal footprint, as Bogdana was referring to. So it will be easy to merge your code and bring it forward. If you are going to deploy this across tenants, guess what? The changes, if they share the same application data, you do the change once and you're free. If they actually have this already deployed, they can still go ahead and customize the rules they have after you implement that for them, just by adding more rows. If you want to add more criteria, it's one column to add and one function to add. What could be a little bit tricky? If you have a table full of data, so as long as you maintain them to make more sense, then it's good. But if they grow beyond that, they won't just be good. They will not be understandable. Now our product is in good shape. It's configurable as well as extensible and upgradable. Let's just make it adaptable to the user needs. So what we see in many situations is we have a product that has a lot of data, but users are different. So you want to present the data to the users according to what they need. So for example, if we have the data stored in a master table, and you want to present this in a different way, using the same table itself and binding it to a page will just result in a lot of data. So we actually suggest that you can use something as a representation layer or an interpretation layer, and that one will be basically a temporary table that we will see in the exam after a while. As you make a temporary table, you basically make this off the main table, and you have the main table validation triggers, but not all of them will apply when you are going to present the data. So you should remove as many of them as you don't need, because you don't apply in this case. And as we all know, our user interface should be free of the business logic. You should have it factored out in code units and tables according to good design practices. How can we do that? We should, as we described, create the table of the main table and use that in temporary case. So the idea basically here is your main table is the model, and you have the view that the user interacts with. This is one hand, and the other has the view. So the layer in between will just take care of offering a subset of the data, getting bound to the page and represented. If we carry the same analogy to NAV, the model in this case is a table already stored in NAV database, against which you can insert, update, delete, all the kind of actions you want to do. And the view in this case is a page with actions and fields and so forth. The layer in between is a temporary table that represents a subset of the actual data. It's temporary, it's shared in memory, it can be used and freed later. So how did we use that in 2015? For the bank reconciliation feature, we keep going with that feature because it's feature-rich. We had some local implementation, and that one was offering good value for the users. But the universal implementation we have in W1 has evolved over time to cover the same features. And on top of this, it even offers integration with importing bank statements and auto-matching, as we described in the previous slide. So with this in mind, now the users have the choice. Should they continue with the local one? So should they move to the universal one? We give them the chance to decide on their own. The business should continue to grow and go on, and whenever they feel that they can move now, they just make the choice. How did we do this? We decided to offer the users a single point to start from, and from that one, if they stick to the local old data, they still can use it from the same place. If they decide to move on and migrate their functionality against the universal W1 implementation, they have the chance. And as they use the role centers, all the statistics showing up on the role centers will reflect the right numbers depending on their choice. And the choice is easily made through the general ledger setup. So basically, the users will be sorting from a list page. And that page will be the access point to whichever cards they need to interact with. And these cards will be dependent on their choice, the local feature or the universal W1 feature. The table bound to the list page itself is a temporary table. And that table holds the subset of the data they are supposed to interact with, depending on what kind of records you use. The temporary table will just reflect the subset out of the W1 table or the local legacy one. With that in mind, we can just look at the graph over here to understand how it works. So the moment the user has the list page open and they start trying to access whatever functionality they want through the page, there will be that question, which one are you using? And that depends on the choice they have already done, they already made. And mapping of the data into the temporary table will be done based on that. If it is the W1 data, then it's clone mapping. If it is the old legacy data, then it's a custom mapping. And we will see that in code excerpts later. Based on this, the users do their actions as they please, and whenever they're done, the data is updated into permanent tables, and everything is in place as they expect. Seamless experience, it works well, and they just made the choice they need. So how does it work? The subset, the temporary table, is built off the main table by finding the proper records the users are using, and then we just make a clone copy. But if we are using the local table, then we actually find the fields, the records they are interacting with, and based on that, we do a custom mapping, as you are able to see over here, field to field as required. Then the temporary table gets bound to the page. So there are different actions on the pages for creating new records, for editing existing records, or deleting them. And all of these are just dependent on some functions we have already implemented in a code unit. And that code unit hosts the functionality we require. So the trick is, we open the page cards that the users will deal with and just hand off the record the page should act on. And that one depends on the user's choice, being the local one or the old one. And the data set, the temporary data set that we are acting against, is shared between the card and the list. And if one of them doesn't act, then the other is informed, and the data is refreshed. So after this, the user gets to use the page. What is good about it? You can, using this pattern, make sure that you present the right data to the right user, depending on their scenario. You don't need to offer the whole thing. You can just offer what they are concerned about or interested in. And one other example that comes to mind is the customer card. The actual customer card is so detailed and full of fields and actions, for good. But if I'm a small business running very small, very basic scenarios, I would rather use the mini app and use the mini card, which offers me a subset based on templates. And the best of all is, you are trying to encourage your users to move on to new features, which will offer them more capabilities. So you still give them the choice when to do that. Because if they're running their business on some kind of feature, they have already done some investment, and moving forward should be done when they are feel free of that. What could be tricky is, that should be used whenever you are going to present the data. That means using your user interface. But if you want the functionality of a view in terms of SQL, that means you should be using a query. Our product now is successfully extensible, configurable, and adaptable. This makes it even more user-friendly. We tend to use .NET classes, different .NET classes, because they offer us some features that we don't necessarily have today in CL. But if something goes wrong with using one of the classes, we get an exception back. Exceptions are very detailed when it comes to error messages, and they're ugly and annoy users. Then we need to handle that. But we don't have the luxury of using a try-catch in CL yet. Then how can we handle the exceptions? So here's an example. Let's imagine that we have a hypothetical feature that is supposed to own a cache, a file cache. And if the file is not there, there will be something to be done. And if the file is there, it will be just used. So the code in this case that will check the file existence and use it later is wrapped in a code unit. If it succeeds, we are good to go. If it doesn't, we have an exception to collect. So following the same paradigm as exception handling in C#, we have catch statements using a case statement. Using that one, we should be able to figure out which type of error has happened using the get.net type CL keyword. And that one helps us discriminate between the different possibilities. So how did we use that, or where did we use that? We had a need to integrate NAV features and extend it through other web services available outside. So we came up with a web service management code unit that helps you, and you should be building on top of that, to integrate with external web services. So when you need to do this, you have a web request in hand that you send it off to the service. If everything is fine, it's good. If not, if something goes wrong, you get an exception back. And when that happens, you need to find out which issue it is and just display an error to the user in a friendly way. We used that with the bank data conversion, where we had some files to change across different formats. We had a master format that the web service is accepting. We send it off. So we get back a file that could be used for payment export or bank statement import, and we even had a service to integrate with for bank name lookup. So that code unit, the web service management, should offer you the chance to integrate NAV within service-oriented architecture deployments and integrate with services and have even more features added to your NAV. So keeping up with the same example about bank data conversion, we send the file in the master format the web service is going to accept, and we get back a file in a bank-specific format. If we get the file, we download it to the client, and the user is free to use it. Otherwise, we have an exception that we need to handle. And from the exception, we get the error and display it in a nice way. So where is the magic? Basically, we have a code unit that will interact with the wrap up the functionality for creating these files. That means we build the web request and run our web service management code unit. We piggyback on the on-run trigger to actually return back a true or a false. If it succeeds and returns true, everything is fine, we should proceed on. If return is false, that means an exception is thrown. And this is the moment when we actually collect the exception and start analyzing it. After we collect it, we have to figure out which type it is. Using get.net type, that's very long to use. Anyways, we collect that and understand what type it is. And as soon as we have it, for the type we expect, in this case, it's a web exception. Otherwise, we just throw it again and it pops up. We get the response out of it and then get the message out of it, which is according to how the web service behaves, will be just an explanation of something is missing, something needs to be changed, currency code is not compatible, stuff like this. So where is the trick here? We have one more keyword to remember today, which is get last error object. That one helps collect the last exception that was thrown. And we use the .NET function for getting the root cause, get base exception. Because usually, when you get an exception back from NAV service, it's wrapped into inner exceptions, a long chain of exceptions. So you have to find out which one is the root cause. Why is that good and helpful? Because as it looks here, it's just easier to customize. You have your CL code in line with your .NET code, and you know both of them. So it will be easier for you and all developers to change. And you carry this on across different versions and deploy that to your customers using text files or FOPs, as you are so used to already. And when it comes to migration across releases, it will be easier to upgrade. You don't have any add-ins or external control that you depend on. It's your CL code and your .NET code to move along. And best of all, you do what you do best, write CL code. But there is a catch. The catch is, if you have chain invocation of code units, so a code unit, you are running it, and that code unit is running one more code unit underneath. If an exception happens, then you won't be able to catch it properly, which means our recommendation is wrap up the code that is expected to throw an exception within one code unit that you run. Just look at Web Service Management Code Unit as an example in this case. Our code is good, our product is fine, and I'm hungry, so it's time to actually do some cooking. Who likes cooking? So time for recipes. The next one to speak about is web services. Let's imagine we have a web service that will offer us some data. And that data is supposed to be up to date to some extent. So the choices we have are, the first one is to continue to be connected to the web service. So the data is always up to date, that's good. But we may encounter network latency, service downtime, all these sorts of things. The other choice is, let's just make a copy of our data back into a table in NAV. And at the moment we do this, the data is already old. It's out of sync. We have to maintain it somehow, and that is expensive. Then what could be the alternative choice? We can actually get the data, pull the data out of the service, cache it, and reuse it. And then we refresh it periodically according to how the business requires this. So if we're going to do it this way, there is one example we have in mind about bank names. These bank names we use to communicate with another web service to figure out which format we're going to change the file to. If we have the data already cached and it's not outdated, we just get to use that one. Otherwise, we will have to figure out which country code the bank belongs to, and based on this, we ask the service to give us the proper bank names for that one, and that is a subset of the overall list the web service can offer us. So the footprint we download here is very minimal, and also only when needed and being outdated. So the data is stored in a table in NAV, like any other table. And it is time-stamped, so it's easy to figure out if it is outdated or fresh. And it gets displayed to the user through a list page. That list page works in a regular mode, like all other list pages, or in lookup mode, when they need to use that from the bank account card. The page is going to offer the chance to refresh the data the moment it detects that the data is outdated. Otherwise, the user is always going to have the option to refresh the data the moment they need to. Where did we use that? We used it for payment export feature, where we generate bank-specific file formats. So we need the bank name to communicate it to the web service that does the conversion, and from this one, we get the right file and give it out to the user. This is how the page looks like, where each of the bank names is already time-stamped and associated with a country code, and the user has this action to decide if they want to refresh it at some point of time. How does it work? The moment the page is approached by the user and open, it tries to figure out which country code we are going to use in this case, because banks are going to be tied to a country. And if there's no data at all, it just goes ahead and fetches the data from the web service. Otherwise, it tries to figure out if the data we already have now is outdated or not. If it is, it just goes ahead and fetches the data again. And now we need to figure out what's good about it. So there is no need to worry about timeouts or the web service being down or no network connections. And as we embrace the cloud-first, mobile-first world, we work across different devices in different contexts, and we may or may not have a proper connection. So if we get the data cached, then it's relatively fresh enough according to what the business defines. What could be tricky is we depend on external services. The more we integrate with external services, the more we depend on them. And the value of the code, the value of the data in this case, is as good as the service is up and running. So with this in mind, I get the chance to hand this off to Anders Larsen, our master chef.
Thank you, Mostafa. Hello. Oh, now I'm on. Oh, so now to something a bit older. Copy document. That's an old function that we have in our application. So as a developer, I cannot live without copy-paste. And if you have to do with a document structure, the user will expect that you will be able to copy from one structure to another or within the same structure as well. And the only way to do that in CAL is to create a code unit for mapping the fields. Something like this. If we just take a very simple flow diagram here, the user create a document header, run the report, invoke the copy document, and we have this little function that do the magic. Looks pretty simple. If we look at it from a component perspective, it looks, again, very simple, but we have a wrapping code unit, a wrapping report, for calling the code unit, and actually we are utilizing the fact that we have that request page so you can key in parameters for free, and that just call this copy document management code unit, that's an awful long name, that do the trick of copying from the source to the destination. But some of the problems you have when you have code units like this, that within NAV we have a lot of implicit implementation patterns. If you look, there are at least two in this code unit. It's, by the way, a huge code unit. It's the third largest code unit we have in our base app. That by itself makes it a bit terrifying to look into. The validation order on our document line, we assume that we have a certain order that we will, after we have created a document line, we will validate it by time, number, and then location variant, unit of measure, and then we fill in quantity and amount, unit price in that case here. So that is actually, even though it looks like we have decoupled the document from the copy document, we have that, we depend on there's a validation order over here. Another implicit implementation pattern is that we need to implement fields in table consistently to get transfer order to work. It is used widely in both copy document and also in posting of document. So number, data type, and length must fit, otherwise. A last word around copy documents. Since it have that high class coupling, it is actually one of the objects we have the highest test coverage for in our base app. So the more you couple code together, more code coverage you need to have. Select distinct. It will be nice to have a select distinct out of the box. In the older days, not that many years ago, you will use set range, find last, remove some filters, find next, or whatever, or fill it into a buffer table. Now we have the query for doing that. Configure some parameters in a query, and have a total column to trigger that grouping. The majority of the audience here are from Europe, so you know we have this VAT thingy here in Europe. The majority of our document will set a footprint in here. Some will set even more if there are more VAT types on a document. And then if you want to have a select distinct in this table based on document number, one line per document number, You can configure that by using type, document type, and document number. And a query, simple query, will look like this. For those of you who remember the old reporting stack, you will also remember that reports back then was actually also very good at doing select distinct. So when we moved our report stack from the classic to RDLC, there were a few issues reported in. Many. One of the issues was around the VAT report, where when people should import the Intrastat or the VAT, we fetch all the VAT entries and send them to the report layer and let the report layer do the magic. It went very well on Classic Stack, but unfortunately on RDLC, it could crash. So that's why we also implemented that pattern here in the report 19 using that query there. And of course, we also have related pattern like user temp table or buffer table. CAL guidelines. When I was a bit younger than now, start developing, making NAV solutions, I was pretty proud of myself to begin with. Then I showed my code to a colleague. He gave me honest and candid feedback. It looked like shit. Then a few days later, I took up myself together to ask him, you didn't like it? And he said, Anders, first off, you are not following any guidelines at all. I cannot read that code. You have wrong indentation, you have wrong spacing, you use wrong variable name, it's oof. And then, back then, in the old days, there was actually a DVD-CVD where there was the guideline visible, and then we were supposed to follow them, and we did that also. When I joined Microsoft 11 or 12 years ago, we also got those guidelines handed out by paper. But you know, put it in. That's not so nice. So 7 or 8 years, we did a gating. So every code we touch or change should follow the rules that we had agreed on to follow. And I hope it have increased the quality, it have at least increased the readability of the code that we are producing. I will not go through all the CAL guidelines here. There's a bunch. Some of them are tedious, space, indentation, whatever. I will go back to where you can find them later on, but let's take a few of them here. 2 rules about parameters. Something with the width scope, sorry. And then this little buzzword, cyclomatic complexity. How many of you know that word? Good. You will learn something new then. Parameters. There's at least 2 rules of parameters. You know, you can declare a string, and you can put in %1, %2, and so on, placeholders there. And we will actually like to have a match when you call that string, that the number of parameters should match the number of placeholders. An obvious one. This example is, of course, a bit simplified. So, to be able to check into the product, it should look like this. Another one that I think is a bit more important, that is calling by reference. When you look at a piece of code or a procedure, I will at least look at what is called by reference and expect that that will be changed in the procedure. We have a rule that if you call by reference, it is not for fun. You must use it. Another one, this is a tricky one. The width. How many of you use width a lot? Oh. So the problem with width is if you use width together with other variables, then you must know exactly what fields are in that table. In this example here, of course, you all know NAV so well that you know that service contract header have a field that is called contract type. What's this one? And it is actually, if you debug, and that often happens when you have to do with width, that you actually need to debug, and debug is time-consuming. In this example here, of course, if you change the calling parameters to be something that is not within the scope of the width, then it goes more gracefully. And actually, often if you use width, that is because you have a long list of fields. Try at least, if you use width, to isolate that into a procedure and have only that little thingy there. This one, CC. It is supposed, according to literature and browsing to the net, to be commonly, widely used. It is an attribute you can use to describe your code, like you don't have to tell young developers that they write shitty code. They have too high cyclomatic complexity, or they have too many lines in the procedure, so it gets something that you can discuss. So how to calculate cyclomatic complexity? It's numbers of decision in the code plus 1. So whenever I come to a new decision, and if or a case, I just increment the CC for that trigger. So here, yes, in CAL, we consider if and case as decisions. You know, you actually see if and if, then I start to think, and the same goes with the case. Actually, when I was researching here the other day for preparing, I realized that for and while are also decisions, so we might look into that rule later on. So now we have a number for the code that we are writing. Some consider 20 to be the absolute maximum. Others consider 30 to be the absolute maximum of high cyclomatic. It also took me a month or two to learn to pronounce that, how high that number must be. We have a magic number in Vedbæk that's called 25, and it is actually so magical that it have disappeared from this slide, sorry. But 25 is the key number. So now, since none of you know what it is, or very few, there is an opportunity for earn a t-shirt here. Remember Mostafa showed a piece of code? Give me the number. Come on. No. Lower. 11 and 30 are close. 1, 2. Who said 12? We have, yes. Super. The funny thing is actually when before I know anything about cyclomatic complexity, that did code here look a bit dodgy, just for the fact of the many lines. And also I know that this is only a sniff of that code. One little additional comment. I said we had the rule that you are not allowed to check in new code or modification of existing code if you exceed 25. We have that little exception because some of you know some code unit, 80, 90, if, case, blah, 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 blah. and not to completely ruin your world by changing that all the time. We had that little exception, unless you only increment with one. But otherwise, that will actually have forced us to, whenever somebody touch code unit 80, to do a refactoring there. We do incremental refactoring on the dodgy code unit from time to time, and we will keep on doing that, but only incremental. We don't have a huge refactoring project going on or have that planned yet. But I must admit also, MC Hammer is close to code unit 80 from time to time. This is a high-risk function to change. But hopefully over time, we will have something more simple than that all over our code base. Now, design pattern, NAV pattern, cookbooks, coming up soon also CAL guideline. Who is a part of this? This is an open project. We are some from Microsoft and some from the partner channel. Could those of you who are present and are active here or named here please raise up, stand up? Mostafa, up. Thank you. Say hi. You can try to search for NAV design pattern on various medias and places. Please, if you read something anywhere, any day around design pattern, give us some feedback. Is it good what we have written or writing, or bad, or yeah. And if you feel inspired to join or contribute with either an idea or a suggestion, please feel free. We have the wiki place, where we publish all our patterns, where there also is a contact person, Bogdana, I can see, if you want to join. So what are we planning to do in the upcoming time? A new pattern per month. Don't take that literally. Understand that as a 12 to 15 over a year. Soon, all the guidelines that we are using in Vedbæk for gating will be published at this wiki. Hopefully later on some tooling also, but to begin with, to have some visibility around what we consider as important to you. And then also, since it's a wiki, you can also give us feedback unless you disagree, have strong opinion, or have suggestions for good guidelines to have. So, think NAV in design pattern. Are there any questions? Yes?
In the, was it cycling?
Cyclomatic complexity. Cyclomatic. Yes?
Also the Fordov be included?
Yes.
In the end, the Ford has hidden if in it.
Yes, a 4 is a decision, and we are missing that, and so a while. Yes, I totally agree.
And the one that said 13, you should give him the t-shirt, because you forgot the +1. Yep.
Yes!
That was a good one.
Actually, that was completely correct. In the example, there was 13 because I forgot the +1, or did I forgot to init my variable, or yes.
Who said 13?
Who said 13? Yeah, that was because we cut off the code so you didn't have to repeat. Yeah, oh yeah, yes. Oh, give one more.
Okay. 14.
That is why we have automated that gating. I don't calc that precisely.
So who said 13?
And 14 as well.
Is there a smart way or smart pattern to avoid field validation order dependency?
If
In modifying
if there's a pattern to avoid field validation and...
Right here?
Yeah.
Yeah, there is a problem if you change validation procedure. You might break validation order in some other procedures. So are there any recommendations about that?
Are you talking about the argument table or generally?
No, generally when you copy document.
In general. Some of the implicit pattern, I hope that we will be able to document them better, either at the wiki side or other sites, and in an ideal world, you shouldn't have that dependency that the class needs to be validated in a certain order. You should have called that class with the parameters, and let's one place take care of the validation. Yes. When I look at something codish or whatever, I take we are where we are and we need to move on to something better. I agree, we have a lot of depth and inherence that we cannot fix overnight. We also have to add new features to keep the product alive. But yes, this is something that we're aware of. We will address that by both documenting that and do incremental refactoring. Actually, the incremental refactoring is the best way of doing refactoring. So you refactor the surrounding code when you're touching something instead of rewriting all of it. Yes?
In the hooks pattern, is there any plans for in Microsoft to extend the hooks pattern also using the argument table, so you can configure your hooks?
Yeah, we might do that. That is something about having a pre and post event more. Sorry, the question was, are we from Microsoft looking into to extending or to enable you to an easy way to do the hook patterns? And we might consider some event of pre and post event. I don't know when it's going to happen, but we are looking into that. I don't know if we'll do it in Corfu time frame or later. But it is something that is nice to have.
Hello. Would you consider documenting in the code units the preferable positions to put hooks in order to get a nice flow of data?
If we will document the code flow on the table, we have to get a nice flow. To understand the flow.
It would be interesting to, in code unit 80, for any beginner to know where to put the hooks in order to get the data to the right places.
So I think the question is if we are going to show from before where to put the hooks.
That's right.
Well, that partly depends on your implementation. So, and I think we don't have any plans for showing hookable places, as we also don't know how we are going to change the code in the future.
Okay.
Is it a new design pattern to use a speaking name for text constants? Because there were some in NAV 2013.
Speaking what?
Speaking names for text constants.
Now you are using the names of the text constants which are longer.
Oh, yes. Yes, and that is for readability, that we will like message to be prefixed with MSG, arrows with ERR. That is to improve the readability.
That's part of our guidelines, not
Yes.
one that we showed today, but
Yes.
we're going to put it on the wiki at some point soon.
Good catch.
But it's not a pattern, it's more like a guideline.
It's an implementation pattern or guideline, style guide.
Yeah.
Yes.
Next question here.
Hello. In Visual Studio, there are several tools to check your code. So what kind of tools are you using, and is there anything planned for Navision?
Internally, we are using a tool called Precal that is a component built in C#. You feed it with a reference file, the latest baseline, plus the delta that you are going to proceed. I don't know what kind of tool we'll be able to offer you moving on. But if nothing else, we will try to see if we can release the internal Precal tool with some direction on how to use it.
Yeah, but generally, to have a professional community working on code, it would be nice to have this tool. However, there is no plan now. We'll see what happens. We didn't get it.
Web service was it, yes.
Hello, one question about the hook design pattern we are using since version 5. And I like to ask if it's a possibility to get current code unit in a code unit. So then I can pass the instance of my current code unit to another code unit to work with. This would help us a lot to make better hooks for code unit 12 and something like this.
Something like this.
That's a good suggestion. We don't have it right now, but we will hand it over for sure.
Actually, it's not the first time I hear this question, so it turns out like there's a repetitive wish coming for this to happen. But again, it's not in the plan now. But I really agree that it's something to have that would help a lot. So the more times you ask, the more chance it is to happen. Yeah.
When you were talking about cyclomatic complexity, it reminded me of a limitation we encountered a while ago when a colleague of mine wrote some a huge piece of code. We encountered a limit that the number of parameters plus the depth, how do you call it, the complexity depth of your code has a limit. I don't remember the exact limit because it was like 5 years ago or more. But if you had a lot of parameters in your function and your function had a lot of ifs that went very, very deep, it wouldn't run or compile even. Is that still present, that limitation?
I hope so. If you have a lot of parameters and a long list of codes,
I agree.
It is not supposed to do that, but another, while talking about cyclomatic complexity, we also have a restriction that you're not allowed to have more than 100 lines in a procedure for good reason, and that should be shorter, if you ask me.
I also have 2 little feature requests that I think will make life easier for the developer. One is an obvious one that's been touched upon. Try catch. Is it planned in some form, foreseeable future, 2 versions ahead or something?
We don't actually have any plans, concrete plans for a try-catch close at the moment.
Because currently the code unit run, like you said, has a limitation in nesting and or multiple during write transactions. You can't use it.
That is true. We are aware of these limitations, and we are trying to see what options we may have. But no concrete plans are in place for the moment. But at least, as it looked like, as we described it, you still will be able to catch the exceptions, because we have this in a live implementation with the web service integration we have talked about today. So it is possible to follow the same approach as it is today. I hope we can improve it further for the sake of everyone.
And the last one, and the last one was smaller, I think, after insert triggers on tables. So you can update totals depending on after the insert. Make code easier to read.
Yeah, this is a good idea that I think that Thomas in the keynote has mentioned, that we are thinking about event-driven development as well. So hopefully that will happen in some point of time. We just hope for that now.
Okay.
Yeah, so actually, one of the nice dreams of people who are writing patterns is to see some of these patterns retired, meaning that they have been replaced by platform features, so we don't have to do the pattern workaround. But yeah, the first step is to find a way to do it, and then if they will be retired, we'll be the first ones to celebrate.
Hello. About pattern testing, not testing, try-catch about .NET in Navision. You use an if code unit run construct. Why you do this? Because it does a commit. I have to commit my data when I use a code unit run.
If you do a if code unit done run, you are handling the error that code unit is throwing. So if there's an error within that code unit, you ignore that.
Yeah,
and handle that by the if.
Not every time when I use a .NET variable in Navision, I want to commit my code.
That is true. It's a limitation we are aware of. So, well, in the limitation we have shown today, we don't have a single line of that is going to commit. The whole process is going to happen, and whenever it is done, it's committed. If something goes wrong, we have the exception in hand. This is a very correct limitation you have just mentioned, and we have encountered this while we were trying to develop scenarios in which we had to run the code unit through our array transaction. But this is what we have for the moment, and we want to improve that. We are looking into how we can improve that. So hopefully in the future, as we improve it, it will be possible to not to require commit if we actually have a different approach for it. So it's something we are aware of it. So thanks for the good question.
I think we have, oh, there's one. Yeah.
Hi, hello. So I have two questions actually. One of them is about this if code unit run. So in your example, the whole concept of if code unit run was to catch an exception and present it in a human readable way. But basically, I have to commit before that. So if I have like asking a web service after something happened, I still want the transaction to roll back.
It depends on when you call that, and it's not called run modal, so you don't need to commit before you do a code unit run.
But if you do call if code unit run, this just will, if you're in the middle of transaction, so basically I'm just writing something into my database and then confirming with the web service that actually it's correct, and I want a human readable error on my screen. So it's not more of a question, but more of a suggestion that to have a command in NAV to actually roll back.
But keep in mind one idea. If you have a write transaction in progress and you want to run a code unit, that actually, well, we have two concerns, two responsibilities here that we're concerned about. So just to map this to the example we had today, we were actually pulling data from the service, and if the data is in place, we will try to use it later. But if I have a write transaction in progress, that means I have some functionality that acted on existing data. I should take care of this one first, and whenever it is done, I should just interact with the service, because the service should be acting on the data I have already on the database. So I don't see a huge issue if I actually well, divide the responsibilities across different ones. So I think it can be redesigned a little bit.
Yeah, I agree with that. So basically, we can use the temporary table then.
In the example we had shown over here for processing payment export files and bank statement files, we take the whole thing in memory and we just go through one transaction. If it succeeds, you have the data, you have the file, you're done. If it never succeeds, nothing happens, nothing gets committed to the database. So it depends on how you approach it. I think you just need to just look at the design once more to separate the concerns first. And if you do that, you will not have the issue of committing before you proceed. Even during our testing scenarios, the automated testing scenarios, we had to create data and proceed with that. So with proper design, we were still able to proceed with that approach, even though we were running a code unit.
Okay, makes sense. Thank you very much. One more question then about the argument table pattern. It all sounds great and good, and I'm using it myself sometimes when I have like very complex functions to run. But the challenge I'm coming across is actually, in this case, if I add a new parameter, and I really want this parameter to be populated, I cannot catch the exception before the runtime, because the compiler will just say, oh, you pass a record, it's fine. But like, for example, I have 10 places calling this function, and I really want this parameter to work fine for all my previous code.
So what you're saying is that if you add a new parameter,
Well,
you add it to the table, and it's not used by the function that should use it?
So, for example, if I do it the classic way, adding it to the function, just compiling all the objects will give me basically the call points. Yeah. So I have just to export everything to text and then just find that were used. Is there any better way?
Well, there is a trade-off between the flexibility and the compile time error messages and detection of issues. So either you opt for this, the flexibility, or you opt for as many parameters as our colleague was mentioning. Then you will hit the limitation at the end anyways. But I think there is a trade-off. If you have 3 or 2 parameters, maybe it doesn't make sense to have that. Exactly. But if you expect your design to grow over time, then you better opt for the flexibility, because it will reduce your maintenance costs along the road anyways. So it's a trade-off you have to decide on.
It's a trade-off, but also it's a good request for further improvement to see where I have used my table, yes. Yeah. Especially as a parameter.
Okay, thank you very much.
Thank you. True.
I see no more raised. Oh, still one over there.
Yes, I think we...
Perhaps more a remark and not a question about the hooks. Wouldn't it be nice to define the code unit or the function as a hook, so we can identify where hooks are used, and when we try to upgrade the code so that we can ignore those parts automatically, so we can identify this line is calling a hook, so we don't have to bother with that.
Yeah, so the platform doesn't help you now with this. No. The only thing that you can do is to post-fix it, suffix it with a hook. But it would be nice to have it, of course. That would help.
Hi. Regarding the functions and the parameters you have when or the way you change the parameters to a table, wouldn't it make sense to use a .NET functionality to have, for example, a key value pair within a .NET class, and then set those values before running the function and just give this .NET variable as a parameter and get the values inside the function afterwards, so you can work with arrays and address the information within your .NET class?
Yeah, so that would be an alternate implementation.
Yeah, so but this way would help to reduce tables and functionality inside NAV to blow up those values you just want to overtake in the function.
Yeah, it depends on how much you want to hook into .NET code or how much you want to keep it CL. And of course, the tables are, it matters for you if you create new tables, so then that's it. But I think the point of the pattern is to gather your data, encapsulate it into something, and pass it to the function. So,
okay.
Yeah, that's a good point.
We have one more up here.
Hello. You said you wanted to get rid of the by reference parameters when you don't return a value. Wasn't it?
Yes.
Sorry?
The function parameters. You wanted to get rid of the by reference if you don't return a value.
It's not that you get rid of it, but you are encouraged not to pass a value by It's an argument by reference, if you're not going to change it inside the function.
Yes.
But for records, we standard use by reference, because you don't copy the data then of a whole table record. Is that you're going to change then?
Yeah. But behind the scenes, the server takes care of managing memory on your behalf.
Yes.
So when you pass by value or by reference, you are just instructing the server, I'm not going to change the value. If a change happens, give me an error. But the server behind the scenes is actually using C# code and these kind of things, and it takes care of memory management on your behalf. You need not to worry about that. You just need to worry about what I'm doing is going to change or not to change.
So you, in the standard Navision, all the table parameters are not by reference anymore?
We haven't modified. We have, and you will see that when we reveal all the guidelines, that you will be able to find violation of those guidelines, because it is only when we change the code we implement the guidelines also.
Okay, thank you.
Yes. Last question? Otherwise, feel free to come down afterwards. Okay, thank you.
Thank you very much. Thanks for the good questions.